All right, thanks for joining us again. This is part 3 of medical acid base. We've talked about a number of things. We've talked about acid base, bicarb, and PCO2. We've talked about the definitions of acidosis and acidemia and things of that nature. We've just briefly touched on the anion gap and the non-anion gap metabolic acidosis. We've talked here about the ways that we can quantify the degree of the acid-base disorder of an anion gap, and I kind of want to review that. So I'm going to throw up once again our Henderson-Hasselbalch equation. So the pH is equal to 6.1 plus the log of the bicarb concentration over the PCO2 times 0.03. And again, we talked about anything that occurs up here is a metabolic primarily. Anything that occurs down here is a respiratory. How they work out is going to determine how the pH is changed. We talked about how are different ways that we can lose bicarbonate. We can lose bicarbonate with 2 different ways. One is by combining with a proton that comes from a conjugate base. If that occurs, we're going to get an anion gap. If we just lose it, it's not going to cause an anion gap because we're not getting any negatively charged particles that are not in our Chem 7. And again, anion gap, just to clarify again, is equal to the sodium minus the addition of the chloride plus the bicarb, and that is normally 12 in a normal situation. And why is it that's the case? Because that is made up mostly of albumin, and a great way of calculating what the anion gap should be is just taking the albumin concentration, which is usually 4, and multiplying it by a factor of 3 to get it. Okay, now I want to show you what the body does in terms of trying to mitigate swings in pH. We talked about that's very important for the pH to stay in the same place. And I'm going to simplify our Henderson-Hasselbalch equation here a little bit to kind of demonstrate what I'm talking about. Let's just say the pH is basically proportional to the concentration of bicarb, okay, over the PCO2, because that's basically what's going on here. Is bicarb over PCO2 is going to work itself out into the pH. So there's several different possibilities of things that can happen. Let's remember again that the bicarb is something that takes a long time for the body to adjust, whereas the PCO2 can adjust itself almost immediately. So let's talk about that. Let's talk about a metabolic acidosis. Okay, what's going to happen here? In a metabolic acidosis, remember this bicarb is going to go down. So bicarb, or HCO3 minus, is going to go down. Now if the numerator goes down, what numerically should the body do to PCO2 to keep the pH in the same place? This is called compensation. What is the lung going to do to PCO2 if the bicarb goes down? Well, you know that if the numerator goes down, the denominator should also go down if you're trying to keep the pH in the same place. So PCO2 should go down. How's the body going to drop the PCO2? It's going to breathe faster. And so you're going to get compensation by dropping the PCO2. So in a metabolic acidosis, your PCO2 is also going to go down. And it's going to go down immediately because the lungs can work very fast. And so it's almost going to be seamless. As this is going down, in other words, as the bicarb is going down, the PCO2 is also going to be going down, and that's what happens in a metabolic acidosis. All right, what about a metabolic alkalosis? Well, you know, of course, that the bicarb concentration is going to go up. And so if the bicarb goes up, what's the body going to do to the PCO2? it's going to go up as well to keep the pH in the same place. And so your PCO2 is going to go up. And it's going to do it immediately. It's going to happen very fast because the lungs can adapt very quickly to this slow metabolic problem. The lungs are going to adapt very quickly. And so metabolic acidosis, you'll see bicarb goes down, PCO2 goes down. In a metabolic alkalosis, bicarb goes up, PCO2 goes up. The key, though, is knowing that the thing that happens second never happens to completion. And so the bicarb will go down in a metabolic acidosis, and the PCO2 will go down, but it will not go down enough to fully negate effects of the first thing that happened. And so you'll still get a acidemia in an acidosis. So the acidosis is caused, the compensation is never fully complete, causing you to have an acidemia. Here in a metabolic alkalosis, the bicarb goes up, the PCO2 doesn't go up enough to fully cover it, so you still have a alkalemia. Let's talk about respiratory. Okay, let's talk about a respiratory acidosis. In a respiratory acidosis, what's going to occur? The PCO2 is going to go up. That's a respiratory acidosis. So what's going to happen to the bicarb? This is the tricky point, because there's actually going to be two conditions. Because the PCO2 can go up almost immediately, and specifically because the bicarb takes days to fully compensate, you're going to have two conditions. You're going to have an early situation where the bicarb hasn't changed. You're going to have a late condition where the bicarb has changed or compensated. And those are broken down. Okay, those are broken down into an acute and a chronic. So there's actually two types of respiratory acidosis. There's an acute respiratory acidosis where the bicarb hasn't had a chance to go up. And you can have a chronic respiratory acidosis where the bicarb has had a chance to go up. And that's why. That's because the kidney takes time. So in an acute, the bicarb goes up only a very tiny amount. Just a little arrow. Put a little arrow there, okay? Whereas in a chronic, the kidney has a chance to compensate. And so you're going to have the bicarb going up a lot. Any venture as to guess which pH is going to be more normalized? It's going to be more normalized in the chronic. Why is that? The kidney has more chance to retain bicarb to compensate for the acidosis. So you have two types of respiratory acidosis again. One because the kidney didn't have a chance to compensate, and another because the kidney does have a chance to compensate. Let's talk about respiratory alkalosis. Okay. Here, PCO2 is going down. Now, if the PCO2 is going down, guess what's going to happen to the bicarb to keep the pH the same? It's also going to go down. But again, just like there was two different conditions in the first one, there's going to be two conditions in the second. You're going to have a situation where the kidney can't drop the CO2 fast enough, and that's going to be an acute respiratory alkalosis. So in that situation, this HCO3 is going to go down only a little bit. And in that situation, you're going to have a worsening alkalemia. Why is that? Because, again, the bicarb hasn't had a chance to drop. And then you're going to have a chronic condition where the HCO3 goes down a lot. It has a chance. It has a chance to compensate. So the chronic condition allows the kidney to compensate. The acute condition doesn't allow the kidney to compensate. And that's why you're going to have different types of pH. The pH swing is going to be much greater in the acute situation. So, for instance, in respiratory acidosis, the PCO2 goes up. And that's going to cause an acidosis, a worse acidosis in the acute situation than in the chronic. Why? Because the kidney has a chance to increase the bicarb. In a respiratory alkalosis, the PCO2 goes down, so you're going to have a more alkalemic state. Why? Because in the acute situation, the bicarb doesn't have a chance to dump that bicarb. The alkalemia is going to become less severe in the chronic state because the kidney then has a chance to dump the bicarb. So in actuality, there are just 6 different acid-base disorders, primarily. 1, metabolic acidosis. 2, metabolic alkalosis. 3, acute respiratory acidosis. 4, chronic respiratory acidosis. 5, acute respiratory alkalosis, and finally 6, chronic respiratory alkalosis. And there's something I want to show you here. Let's take the metabolic acidosis here. What's the pH? The pH here in this situation is pH is down. What about in the metabolic alkalosis? The pH is up. What about here in the respiratory acidosis? Well, pH is down, pH is down. And here, respiratory alkalosis, the pH is up and the pH is up. Now, I want you to notice something. Whenever we have a metabolic process, the PCO2 and the pH are going in the same direction. In other words, whenever the pH and the PCO2 are going in the same direction, you always have a metabolic process. Whenever, in a respiratory, however, on the other hand, the PCO2 and the pH are going in opposite directions. Okay? So pH and PCO2. Always look at the pH and the PCO2. Remember, those are the first numbers on your blood gas. The pH first and then the PCO2. You'll see that if they're going in the same direction, it's a metabolic primarily process. If they're going in opposite directions, then they are respiratory. And this concludes part 3. Let's go to part 4 next. And we'll develop this a little bit more and make it a little bit more easy to understand. Thank you very much.